Hey, listeners, before we get into this episode, we have some fantastic news. You know, my K-12 Developing Mathematical Reasoning, Avoiding the Trap of Algorithms book came out earlier this year. Super excited. It hit top new release and bestseller. Ow! Well, I'm even more excited to announce that the grade band companion books are about to be here. The K2 companion book, Developing Mathematical Reasoning, Daily Strategies, Tools, and Activities to Teach the Big Ideas in K2, say that 5 times fast, is coming out soon. And we are having a launch webinar on October 8th at 7 p.m. Central, 8 p.m. Eastern, 5 p.m. Pacific.
And you are all invited to celebrate with us, especially K2 teachers and coaches and math leaders. Pam is going to share tons helpful things to teach K2 math that is more figure-outable.
Yep, I'm going live on October 8th to show you how you can get the most out of teaching our youngest students to math in all the best ways.
You're going to want to join us. To register, go to mathisfigureoutable.com/DMRK2 webinar. We'll see you there.
That's mathisfigureoutable.com/DMRK2 webinar. Now on to the episode. Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Because we know that algorithms are super cool human achievements, but y'all, they're terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop. I had to take a breath that time. Couldn't do it without. Sorry.
In this podcast, we help you teach mathing, building relationships with your students, and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. And that also means I need to work out more or something. Is that a sign? It's a sign. I got to get more air. Hey, Kim, I'm going to tell you today, we need to do a shout out. So I had a meeting the other day. So I meet with schools and districts. We work with schools and districts, and we work with our learning suite. And it's amazing what we can do. Y'all, if you're a school district leader, you should get with us because we love working with schools and districts. And I was on a meeting the other day with Noreen, and I am going to shout out Noreen and Kathy. Y'all are amazing, and we are so looking forward to, we're going to start our work with them in days, and just thrilled to be working with Methuen School District, and you guys are amazing. Woo! All right.
Super fun.
Second thing we're going to do today is I want to tell you a story, Kim. So I think I mentioned this to you the other day. I was on a plane, which I do often. And, I don't talk as much on planes. I don't know if it was COVID or if I just
Which is funny because every time you go on a trip, you come back and you're like, hey,
have a
so I was
story?
talking to this person. I'm like, I don't talk to anybody. It's like quiet time. Shh.
Well, I don't usually, I don't know. I don't so much anymore.
Okay.
I had a very delightful conversation with a businessman.
Okay.
He was a sales guy, and we actually talked about some business stuff, and it was interesting, because Math is Figure-Outable is a small business, and I'm a math teacher. I don't do business. So, I'm trying to figure out how to do that. And anyway, it was super interesting. He asked me what I do, and I kind of gave him a little, the spiel I usually give people. And he told me it was terrible. I need to come up with a better elevator pitch.
No.
That was good. He liked our mission. He just said my elevator pitch was bad, which is good. It's good input. I'll take his input. But one of the things that he said was he heard me, talk a little bit about how we're shifting the way we teach math and why, and how the way mathy people think is not rote memorizing, mimicking algorithms. And he said, well, let me tell you, the most important thing that was true for me as a student was that my teachers had me memorize multiplication tables. And I was kind of curious for him to say that. I was like, well, that's kind of against everything I believe, but I didn't say that. I'm trying to get under kind of what he's saying. And he goes, yeah, they gave us this table, this chart. And he kind of, was moving his hands, and he's like, there was, all those facts in there. And he's like, it was so important for me to memorize those. And I said, I'm kind of curious what you mean by that. Say more about memorize.
Yeah.
He dove into, he said it was, the relationships between that. I could realize how this one was related to that one, and these were connected to those. And it was all this interrelated, consistent system that all was meaningful. And it had, and I thought, and I said, so like when you say memorize, and you looked at, say, this one right here, and it was like, I don't know, pick one, 6 times 9 or something. I'm like, does that, you were like 6 times 9 grows on the vine, and so it's, I don't have a rhyme for this, score, so it's 54, like whatever, I don't know. Is that how you memorize it? And he looked at me like, no, idiot. I mean, he was polite, but it
Yeah.
was like, no. And I was like, so when you say memorize, and then again, he launched off into this, yeah, because you need to know how it's connected to like 10 times 6, and how, or I could think about eight
Mm.
sixes, it's like double 4 6s, and it's one more 6. And Kim, everything he said was about how the facts were related to each other and the connections between them.
Yeah.
But he thought that he gained all that because his teacher forced him to, quote unquote, memorize the table. That somehow, as a student, when he was given that table of facts, it was enough for him to make those connections and relationships and build on them and travel the mental path of figuring them and connecting them between each other. That's what he meant when he said, it was so important that my teacher made me memorize the facts. He didn't mean rote memorize at all.
Yeah.
I
You know what? I wonder if that's what he thinks, quote, memorizing is. I wonder if like his teacher put the table in front of him and he was like, "Oh,
You
there's
need
this
to know
cool
these.
puzzle thing," and like look at it and mess with it, and he was just left alone with it, and he looked for things, and maybe that's what he calls memorizing, but doesn't even realize that that's not what other people necessarily do. Like they're
Or
literally
heard.
like naming numbers over and over again.
Yeah,
Interesting.
and maybe skip counting to fill in the table. So in other words, many students could hear the teacher say, "Here is this table, you need to know this." And students could do what he did. I
Uh-huh.
think that's what my son did.
Uh-huh.
Students could do what I did. Well, I didn't see, I was never given the table. I was given flashcards, and so
Yeah.
for me it was just repeated exposure, rote memorizing.
Yeah.
I did have some rhymey things for a
Mhm.
few of them that I couldn't just remember to get the ones I didn't. But I think there are many teachers and students out there that say, you should know this. Okay, let's see. I see the relationships of skip counting. Consider, teachers, that if you've got kids who have built some additive reasoning and they're looking for patterns in the table, that might be the only pattern they see is the skip count. So
Mhm.
then they say to themselves, okay, I guess if I'm going to know this, quote unquote, whatever know means, I guess I'll skip count to recreate it. And
Right.
then they grow up and they become a teacher and say, tell their kids, you need to know this. All right, everybody, recreate this every time you need a multiplication fact,
Right.
recreate the table by skip counting. And we're sort of keeping kids in that additive reasoning.
Yeah.
Yeah, so it's interesting. It's fascinating to me, the words know and memorize and how we connect it with facts, and words matter. In fact, Kim, I was just on a call this morning with Sam. Oh, golly, I think her last name is Parks. She's from Number Club. And one of the things that she and I were talking about is the more that she writes, we're going to talk more about Number Club in the future, but the more that she writes about Number Club, how she's becoming, maybe not becoming, she's aware words that we say words that mean different things to different people, and how she's being very careful to define her terms. And I think she's about to write a blog on the word play.
Mhm.
And Kim, I would love to hear you. Okay, on another episode, maybe we could talk more about, like, when we say play with mathematics. I am 100% sure that what you mean by play with mathematics is 100% different than what I meant when I was a student in math by
Mhm.
playing with mathematics. Like
Mm.
I would have had not even a vision of what it, not even close to what you would mean. Anyway,
Mhm.
so words matter. And I'm just going to suggest today that memorize that, like, what do we mean when we say that? And then specifically with facts, memorize, does it mean to know? Oh, Kim, the other day, in one of the things that we're writing, I can't even tell you which one it is. One of the things we're writing, an editor popped back and said, I said something about own the facts. And the editor came back with, why don't you just say know the facts?
Mhm.
Well, Kim, like, do those two words mean different things to you?
Absolutely. Yeah.
Wait, say more. Like, what? Absolutely. Can you put some
I can
words to
know
how
the
they
answers. Yeah, I can know the answers to individual problems, but not own them in such a way that I can relate them to something else. I can't make connections. I can know individual facts. But when you own something, it's like you have I don't even have the words. You have facility over it. You have relationships to other things. You like know it deeply in such a
deeply
way that you can
in and out, uncompress?
yeah,
There's a
you can
word.
flexibly do things with it. Yeah.
Yeah. So you might have a fact at your fingertips, but you can uncompress it and have lots of relationships and connections and deeper. Yeah.
Yeah.
All those words.
Yeah.
All right. So if we were to say that we want kids to know their facts and more, what's one way that that could look? No, there was something else I wanted to do before I went here. One of the things that he said on the plane was something about napkin math. And I feel like Kim, I mentioned that to you, and you were
Yeah,
going to
yeah.
say something about
Yeah.
napkin math.
We were talking and you said that this man often did napkin math.
Hmm.
And I think we were talking about what does napkin math mean to you, to me? And you said, I feel like it doesn't mean that people just grab something and like write an algorithm on it, that there's some like playfulness to it. And I said something like, well, even if they are writing algorithms, which I suspect maybe they're not, but even if they are, it's probably that at least they have a desire to mess. So like in that moment, they're like, oh, I've thought of something. I'm going to sidestep. I'm going to do some things, which means they probably think that it's within their capacity, that they have access to whatever it is that they like want to stop the conversation. They want to sketch something out because it's burning in them that they want to handle it.
And they can handle it, and
Yeah.
handling it then gives them some information they can move forward with.
Yeah.
Yeah, absolutely.
Yeah.
And I wonder how many people out there are doing quote unquote napkin math that think, oh, that's just a trick I taught myself because I can't really, I don't, whatever. When in reality, they're using relationships and connections nicely. I also
Uh-huh.
wonder how many people think, well, yeah, that's like, there's school math and then there's napkin math. And I'm like, why can't we teach all that? Like, that's real. It's not, let's teach that.
Well, and I wonder how many people are at dinner or in a meeting or in a whatever, and somebody raises something and they don't engage. Like every single notebook I ever have in every conversation's got something sketched down on it. But I wonder how many people go, "Oh, you just said numbers to me," and they don't like they just deflect, they avoid,
Or they
they don't.
believe, or they
Hmm.
believe. They're like, "Oh, that's what you got? Okay, I have
Uh
no
huh.
idea how or
Uh
how
huh.
that's related, but
Absolutely.
I'm gonna believe." And you could be a magnitude off, right? An extra zero in there, like,
Sure.
but because yeah, that was me. That was me early on, absolutely. So, Kim, how can we help kids gain what this delightful gentleman on the plane gained?
Yeah.
How can we do that? Well, one way we can do that is problem strings. So, I'm going to run you through just a quick problem string that can help students not only gain the facts, but gain the kind of relationships that this gentleman was talking about and even more. All right. So, we're just going to run with what if I were to say, hey, Kim, let's picture a bag of oranges,
Okay.
and that bag of oranges has 8 oranges in it. I've just drawn a ratio table, 1 bag to 8 oranges. How
Yep.
many oranges would be in 2 bags?
16.
And I'm going to just do some scaling arrows to just like double the number of bags, double the number of oranges. How about the number of oranges in 4 bags?
32.
Now, at this point, I might pause a little bit, ask kids how they're thinking about doubling 16, just to get that out because kids might not know double 16. If
Hmm.
we're working on learning the facts, they might not know double 16, so we might just do that off to the side a little bit. How about 8 bags?
64.
That one I'm not going to spend time on. How about 10 bags? This might sound familiar with the problem stream we did last week because these are good.
Yeah.
These are
Yeah.
good relationships. Yeah, 10
Uh,
bags.
80.
80. And then I might talk about how they got 10 bags, 8 and the 2. They might know the times 10. For sure, I'm going to notice the times 10 because if kids are learning their facts, they might not know the times 10. So once we add the 8 and the 2 bags and get 80 oranges, then I'm going to be like, hey, check it out. If from 1 to 10, that's times 10. Look at that 8 times 10, that's 80. It happened again. And I'm going to say
Hmm.
it happened again because I'm going to point that out every time. Every time a times 10 happens, I'm going to point out, look at that. It did it again. 8 times 10 is like 8 tens. It's like
Hmm.
8 in the 10 slot, 0 ones left over. I'm going to just notice that times 10 thing. You're like, okay, so I just want to point out so far in this string, we got kids thinking about eights. 2 of them, 4 of them, 8 of them, 10 of them, thinking and reasoning. They're using relationships. Pam, you want kids to do that every time? I'd rather have kids just know. I don't want them to necessarily do it every time, but I want them to be able to if they don't remember. I want them to have these relationships that they don't remember. 8 times 8, they could double to get there. But notice I'm building a lot of other things. They're doubling, got the times 10 pattern happening. Then I'm going to ask them 9. Now, these numbers are in order on purpose. I want them to be able to use what they have up there to get 9. Kim, what's one way they could use what's already up there to get 9?
They can start with 10 packs is 80 and then subtract a pack.
And so 80 subtract 8, that's 72. Cool. Could have also added the 8 and the 1. I'll probably share both of those. Then I'll say, how about 5 packs? That's on purpose. 40. Thank you. That's on purpose to come after the 10. I'm definitely going to have kids have 4 packs and 1 pack, and that's okay. But I'm going to want to encourage them to think about half of the 10. If you don't have to know your 5s, if you know your 10s, double or divide the 10 packs to 5 packs, divide the 80 packs. I just said packs. Bags and oranges, divide the 80 oranges in half to get 40 oranges. Cool. So far, we've just, in a very quick kind of way, gotten kids to think about 2 times 8, 4 times 8, 8 times 8, 10 times 8, 9 times 8, 5 times 8. We don't have them all yet. Let's go 7 times 8. Now here I could have gone 6. Today I'm going to choose to do 7 for reasons. Is there anything up there that could help you?
Yeah, we just did 5. So we could do 5 bags and 2 bags.
We have the 5 and the 2 and 40 and 16 oranges. Bam. That's not too bad. That's 56. Okay, cool. I might point out to kids, hey, do a lot of you know 5 times 8? And if you didn't, you could cut it in half. Bam. You know 2 times 8. Just look how easy it is to add 40 and 16. Sweet. There's 56. Travel that path often. But here's where it gets fun. We don't just want to build. We want to build the single digit facts, but not just the single digit facts. Now I might say, yum. I like oranges. How about 70 bags of oranges? How many oranges are in 70 bags?
It's 560.
And you did that how?
7 scale up times 10 and 56 times 10.
Nice. Then I might say, all right, we got 70 bags. That's a lot of oranges. How about 75 bags of oranges? I wonder if there's anything up there that could help you. I don't know. Maybe not. Go ahead.
The 70 bags and the 5 bags we already found make 560 and 40. So 600 oranges.
That's even a nice addition. Wasn't too shabby. Hey, let's go. Really like oranges. Let's go for 100 bags. 100 bags of oranges.
800 oranges.
800. Lots of oranges. Crazy. Bam. That's too many oranges, Kim. Silly. Just 97 bags. 97 bags.
Okay. Well, I want to remove 3 bags of oranges, and I don't see that you have 3 bags on there.
Rude.
I know, but I know that we have 1 bag and 2 bag there, so I can add those.
Okay.
Or I can think about what's right in the middle of 2 bags and 4 bags.
Oh, nice.
So anyway, that's 24 oranges. So the 800 minus 24 is 776.
You could play a little I have you need there. Kim, if you weren't as over as you are, was there anything else that kids might have done to get the 97 with what we have?
If you have 9 bags, they can make an entry that's 90 bags.
Okay.
And add it to the 7 we already have.
And so like 90 bags if 9 bags had 72, 90 would have 720. We had the 7 bags, so we could add the 720 plus the 56 oranges in 7 bags, and that could also get us 776. Yeah. Nice. Cool. Okay, last problem. What if we were at the race and we counted 784 oranges and we were super curious how many bags we bought? 784 oranges. How many bags?
Well, we just did 97 bags, and that was really close. 776 is only 1 bag away from 784. So then it must be 98 bags. 98 bags. Nice. Is that also 2 bags, 16 oranges under 800? 784, 16. Nice. A couple different ways to. Cool. So, Kim, we are suggesting to teachers out there that we can do problem strings to help kids think about 8s that then lead into things like you just found 97 times 8, thinking and reasoning. You found 75 times 8, thinking and reasoning. And you found 784 divided by 8, thinking and reasoning, using what you know. And
in the process building multiplicative relationships, building multiplicative reasoning. So we're getting the facts, multiplicative reasoning, place value, reasonableness, magnitude, all sorts of things. A sense of what division means is happening, a sense of what multiplication means, a feel for operations. I wonder if a kid ever ran into a word problem that said, I have 784 lovely oranges.
Mm-hmm.
If oranges come eight oranges in a bag, how many bags do I have? I wonder if a kid can go, oh, this feels like something I've done before. I have felt this oranges in bags before. I can dive in. In other words, what they're not doing is going, let's see, keyword oranges. Nope, I don't remember that as a keyword, right? They're not doing that.
Yeah.
They've been reasoning. They've been in a situation where their brain has traveled this reasoning path. Word problems just become, in fact, Kim, I didn't even tell you, our editor said to me on Sunday, he said, hey, that last episode that I just edited, so it was all about word problems, which was an episode that came out just a minute ago. He's like, I really like how you said, if we get kids reasoning, then word problems are we keep reasoning. It's like,
right.
Yeah, that really hits.
Right.
Yeah.
I think everything that you just described that's happening in this problem string, you just listen to their reasoning and their doubling and their all of those things. I think there are kids like the man you met on the plane who probably see a multiplication table and their brain travels through those things. But we've got to do better by giving kids experiences so that not everybody who is doing that naturally has somebody helping facilitate that learning for them, because they're capable. We just have to do things like these problem strings where we are exposing relationships so that they can grab on.
Nicely said. Yeah. And even the guy who did it naturally, why leave him to do it on his own?
Right.
Like, he could have gone further faster if we would have actually helped him. And now that we know how to do it, we can. Y'all, I am reminded of an email that I got just the other day. I'm going to butcher his name. I'm so sorry. Sundaram. I'm sorry. Delightful email, who said, would you consider rote memorization and meaningful memorization? The difference, what is needed for fluency, is the second type. Fluency is meaningful memorization, which can also be described as, he said, remember by repeated use in the right context. I'm going to say that again. Remember by repeated use in the right context. So you're sort of saying memorization could be linked to, we want to remember. Well, we do. We want kids to own their facts. That means they remember them, but we're going to get that memory by repeated use in the right context. And use, repeated, is that what we just did in this problem string? Repeated generating, repeated finding, repeated reasoning. I might say remember by repeated reasoning in the right context. But I really like that. Like, is it rote memorization? No, it's meaningful memorization. If the way we're defining memorization is remember, it's the remembering part by repeated reasoning in the right context. I really like that.
So good. I appreciate that, redefining what memorization means.
Nice.
All right.
Nice.
So we have another lovely download for you. If you would love to grab it, it is www.mathisfigureoutable.com/facts. mathisfigureoutable.com/math.
You can do it. You can do it.
I'm so
I'll
done.
Do it. mathisfigureoutable.com/facts PS, because it's facts problem strings. So it's facts PS will get you facts problem strings. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Don't forget, go to mathisfigureoutable.com/DMRK2 webinar. Can't believe we gave you a link that long, to register for the free Developing Mathematical Reasoning Daily Strategies, Tools, and Activities to Teach the Big Ideas in K2 book launch webinar taking place on October 8th. That's mathisfigureoutable.com/DMRK2 webinar. We will see you there.